Thanks everyone for joining us today for how to operationalize machine learning. I'm Scott King over at Krita Software, and I'm joined by Luther Birdsell. Luther, how's it going in the Pacific Northwest?
Hey Scott, we're off to a great start here today.
Well, good, good. We plan on going pretty quickly today, 30 minutes or so, given the number of questions that we may have. I'm pretty good at assuming what the questions will be, so I plan on covering those as we go along. But if you do have a question, we've all been on a webinar before over the past 18 months. You know how to do it, and let's get rocking. So what we're going to do is we're going to talk about AI, just why some of the projects fail, some of the key indicators that you may look for in case your projects are maybe not as going as smoothly as you think. And then we'll explain how some of our customers are using Krita to help ease some of those pain points, right? So machine learning sounds hard. It's not really that hard if you do it correctly, but I really like this quote from the CTO over at IBM for AI. It basically says, if you're not applying AI, you're just going to be left behind. So look around at your competitors, and the speed of execution, the speed of decision is really the key. Really, we have all these digital tools, digital footprints, and processes that we need to go quickly, and we need to be nimble. Luther, any thoughts on this? I mean, this is pretty much a no-brainer, right?
Yeah, Scott, one thing I would point out though is that we've all seen, Google and Amazon and LinkedIn and Facebook and digitally native businesses apply AI and machine learning and just create huge sustainable competitive advantage. But the way that businesses that existed before a database drove the entire business, which quite frankly is most, um, need to approach this technology differently to be successful, which isn't always necessarily intuitive. I kind of tend to look to, folks who have been successful and try and emulate that, but they have so much more data, and there's some other unique aspects of those businesses that, make the example of like what's possible with the technology very relevant, but the how to get there is different for digitally non-native businesses, at least for most digitally non-native businesses, than it is for the Google, LinkedIn's, and Facebooks.
Yeah, that makes a lot of sense. And that, when people say that technology is disrupted, or, the company is a disruptor, they're basically the digitally native, as you say, right? Because they just have less constraints, right? They can move quicker already, but and they apply AI, but what we're talking about today is how AI in production is just challenging, especially as you talk about the non-digital native companies, which are most of the ones that we talk to, right? I mean, they're the ones that are trying to gain an advantage using technology.
Exactly, Scott. And one of the luxuries that Google has, and we'll just use them as the example, they search the internet 3.5 billion times a day, and they can afford to be their AI can afford to be wrong a ton. I mean, think about how many of those ads do you actually click through, and then of the ones you click through, how many do you actually buy a product for? I mean, for me, it's pretty small, as it is for most of us, but Google can still make a ton of money doing that. Most businesses don't have the luxury of having AI that's highly profitable and can be wrong that much. So developing AI with a lot less data is harder, and it has to be much more resilient and accurate. And it's really what we're going to look at here today.
All right, perfect. Yeah, Google has has lots of chances for failure, right? Baseball comes to mind. You probably only swing the bat, 27 times, something like that during a game, if you're lucky. And,
Right.
You can't get that many hits. But so we're going to talk a little bit about what happens, from a percentage level, right? So out of 100 machine learning projects, surprisingly, 85 of them fail. That seems like a lot, doesn't it, Luther? I mean, 85 out of 100.
Yeah,
That's
Scott, it really does, and I think it's important to unpack this a little bit. So 85%, the Gartner report it said that 80 that surveyed that 85% of these AI and machine learning and data science projects, which are all kind of equivalent statements, that they fail. Specifically, it's that they fail to deliver the value to the business that rationalize the budget to start the project. And if we compare that to traditional software, half of traditional software projects are still failing by that. It's really the highest bar. But that still means that the failure rate for AI is 70% higher than traditional software, and that's alarming. That's not sustainable. And one of our primary missions is to reduce that failure rate and help our customers succeed in spite of all of these challenges.
Yeah, it'd be pretty disappointing to go after a machine learning or an AI project to gain a competitive advantage, only to fail at doing so. I mean, you're still just left behind.
Right, especially when Scott, the internal data science team and the subject matter experts have developed AI that really could help the business. But then, for a variety of reasons, the business isn't able to adopt it. Those are the real, I'd say, tragic failures, and the ones that we are most focused on helping avoid.
Okay. And then, so of those 85, Luther, many fail because companies lack data infrastructure. What does that really mean? Does that mean the hardware, the clean data? What does it mean by data
So,
infrastructure?
Scott, I read this as kind of a broad catch-all, that there are certain businesses that have a strategic initiative to start an AI project, but never get they just don't stick with it long enough to get through some of the initial challenges of getting their data into a form that is readily compatible with AI and machine learning. It's kind of an aphorism almost in the space that the data prep is the hardest part, and I think that's kind of a misnomer. That said, it is a time consuming can be a time consuming and tedious part of this. So it really requires focus, proper planning, and then a consistent theme through all of this is that you have to have the right resources in place, and not everybody with a data engineer or data science title is really, in my experience, capable of delivering the capabilities in the timeframes necessary to really deliver on these value propositions.
And then whose job is it, or whose role, or maybe an organization, if is to get the data ready? Is the business with the problem that has the data, or is it the data scientist that needs to accept the data and run it through the model? Like whose job is that? If it's a little bit of both, probably you'll tell me, but like if someone was like really on the hook for it, who do you think that is?
So, Scott, ultimately it's the chief executive who got the money from the board, got budget approved from the board of directors to start these, really costly initiatives. Ultimately, he or she is on the hook for this. Of course, that those responsibilities get delegated down in the organizations. The only companies that I'm seeing succeed at delivering scalable value in a predictable way with these technologies treat the entire process as highly collaborative. This is the, in general, I think there are a lot of lessons from traditional software that are not getting applied to AI projects that can really help them. But one of the areas that AI projects are different is that the division of labor is not as clear, is not as clearly delineated as it has been historically in software projects. And data prep is a great example. This has to be highly collaborative. Data scientists rarely know enough about the business to be able to do this autonomously. I say data scientists and with data engineers. Similarly, subject matter experts typically don't have the technical skills to deal with this data especially in a scalable way. So something that we just really emphasize, and I think one of the greatest strengths about how we are approaching this problem is just the huge emphasis on collaboration throughout the process.
Okay, makes sense to me. You talked a little bit about the data science lacks certain skills, the business people lack certain skills. Um, there was a report that came out and it quoted LinkedIn as having, 150,000 individuals with data science skills. Yet, um, you know, the job market is interesting right now. What do you really think the skill shortage means? Does that mean people that can't access the model, or people that can't, um, use the model for the business problem? So it's kind of a jumbled up question. Sorry, but what do you think about skill shortages?
I got it, Scott. And one of the things that we see all the time is that this is a pretty widely broadcast concept. Data prep's the hardest part, and there's not enough people to do it. Are two very commonly discussed concepts around the challenges here. But then, when folks go to LinkedIn and they see, they go search for data scientists, and there's just tons and tons of people. They search for data engineers. There's tons and tons of people. What we see, we see in software, what I've seen in software engineering, and I think this is true of most professions, right? Most of the real estate is in this country, both commercial and residential, is sold by a tiny fraction of the real estate agents. Similarly, most of the value that I've seen contributed on software engineering teams, again, all kinds of teams, tends to come from relatively few people. It's kind of a Pareto, like 80-20, kind of distribution, 80% of the value from 20% of the people. That concept, in my experience over roughly the past 10 years in the, really exclusively focused in the AI space, Scott, is that it's even more polarized and even more extreme. So it's not that there aren't enough people who identify as a data scientist or data engineer, or who, have some experience around it. It's that the number of them who can really drive digital transformation in a time efficient way. And remember, time is key for delivering value. Um, that is a small fraction of the total skill set available, and the market for those folks is incredibly competitive. And the reality is, Scott, a lot of businesses just aren't willing to pay for top talent, and they're falling short as a result.
Okay. Well, maybe we can lower the bar for the skill set required, right? So we'll,
Nothing like low code, no code solutions to help democratize challenging technology, Scott.
right, right.
Got
That's
a few
it's a little, yeah, a little teaser of what we're going to cover here in about 5 minutes. So lack of transparency and common goals. I can imagine, um, an argument across maybe a conference room of someone that knows a lot about machine learning, and nothing about business, and somebody across the table knows a lot about business and nothing about machine learning. Maybe that's what this is talking about, right? So if I'm a machine learning or let's say data scientist, and I get my model, it's tuning, it's getting better and better and better and better. The business guy really doesn't care, because he still doesn't have answers. Is that what this is talking about?
Yeah, Scott, I think there's a couple things here, and that there's, I think, a few layers of kind of subtext to unpack here. So first and foremost, we had talked about just traditional software engineering, and today, we've been doing this for many decades, a few generations, and we still have half of these projects failing to deliver the value that rationalized the budgets to start them. Which kind of means you can look at two ways, right? People are still way underestimating these projects, and even the ones that maybe are estimated accurately, they're failing to deliver. It's over 20 years that we've been doing this. Something I see just again and again and again is in the failing projects, they don't start with a business objective that is sponsored by the chief executive, that align with top line initiatives, top priorities in the business, start with a business objective and never take their eyes off it. That is the reason for doing this. It's not about the data scientists. It's not about people's individual fiefdoms. It is about aligning with top line initiatives that have, strategic support. The same is true of AI and machine learning. And I think it's the biggest mistake with AI that we're not taking these really fundamental proven lessons from software engineering and applying it to AI, which, there are some things that are different, but fundamentally approaching this as, we are investing in digital technology to increase the value of the business. Fundamentally, by enabling more revenue at lower costs. And the focus on that, the companies that are focusing on that are delivering scalable value with not only traditional software, but also with AI. Um, so that's the main my main headline around that piece.
Okay. And then to sum it up, we're just calling it that the rest fail from lack of operational process. So maybe that's what you're talking about. With the software development process, people have, or organizations, I'll say, they have pretty defined processes, right? And maybe for some reason they're not following the same with their AI projects. I wonder why that is. Are they not equating the two? Is it a skill set? Is it a culture? What do you think?
Yeah, Scott, there's two things here. Software, traditional software is iterative. It changes over time in kind of predictable blocks. Machine learning and AI are highly experimental. So the inputs to essentially to the system are changing more frequently, much more frequently, sometimes hundreds or thousands of times more frequently with machine learning models than we did with traditional software, which means that kind of traditional approach of a UI developer kind of coding a form to interact with the software without requiring software engineers or other assistants doesn't really work as well. It doesn't scale as well if the inputs to the system are changing, could be changing constantly. So one of the things that we've done, and this is part of AI and ML ops, is using template-driven interfaces that dynamically respond to the models such that there is a mechanism for the users to get predictions from the underlying machine learning models themselves. It's a self-service capability. Now, once that's in place, though, that I'd say the self-service capability is a necessary but not sufficient condition for success. Two other things that are required are the users, the end users, the decision makers, have to be able to access the data, which typically comes from many different systems and on an increasing basis from several other models as well, to get the inputs to generate a prediction from a given model. So just interacting with a whole bunch of systems and other models as a prerequisite for generating a prediction from, having the data to enter on this form is kind of step two. And then I'd say the third piece then that we have that really brings it all together and is kind of the holy grail here is that the business users, the strategic decision makers have to trust these models or they will never get used. So it's the having a UI, empowering the users to be able to enter data into that UI, and then actually trusting the models enough to include them in the decision process are kind of the three pillars along the last mile. The companies that are checking those boxes are delivering scalable value from this, and to the point of the quote that we started with, they are pulling away from their competitors in an increasing and almost alarming rate at times. So we're going to look forward to unpacking that in a little more detail with some of the case studies.
Okay. So you gave us three things that we need. I'm curious if out of four of these projects that are actually in a production out of 100, I wonder if they have kind of that approach that you outlined, or they got lucky. What do you think? If only 4% actually deploy to production, you know, is it that maybe they're more mature? We don't know what companies these are from this research, but hopefully they have a process kind of put out that they can repeat and then they can learn on, right? Like you said, it's highly iterative. So hopefully they can get a flywheel effect going with here.
Yeah, definitely, Scott. The other thing, I haven't had an opportunity to speak to the analysts from Dimensional Research who published this report. Um, I think getting a model deployed to production to me reads as a necessary but not sufficient condition for delivering value. Because again, a model deployed in production doesn't necessarily have a self-service interface. It doesn't necessarily include a mechanism for the decision makers in a truly codeless and very quick way to be able to access all the data that they need to generate a prediction. And look, I mean, how much software have we seen in our careers get deployed to production that nobody ever used because they didn't trust it? So I mean, as alarming as it is that only 4 out of 100 are getting to production, that to me is not a does not mean that those four are all delivering business value with those production models.
Yeah, those four may not be current today, right? Could be three, two, one, could be five or six. Who knows?
Not
But
enough. Whatever it
yeah,
is, not enough.
it's not enough. If half of all software projects are successful, at least we need to get there, right? That sets the bar.
And again,
Um,
that's a 70% delta between 50 and 85%. And look, if we're gonna say 96%, that's even more extreme. But there's a huge amount of ground to cover that hey, we're looking into right now.
Yep, yep. All right. So the point, there's got to be a better way, right? And not to confuse you, we are from Krista Software, so we think that we have a better way. But Luther, you talk about this last mile for machine learning projects all the time. What does that really mean?
So, Scott, this is a buzzword, last mile, that we've used to describe all kinds of innovate of really taking innovation and connecting it with people in a way that really improves their lives and improves their businesses. This is a traditional thing like from electricity, right? You can have, power running all over the country, but if you aren't able to get it into the individual homes, which is, then people don't have lights, they're not benefiting from it. We're certainly not coining this new phrase. We're taking a traditional one and applying it here. First piece is that, we have to start with these business objectives and that there is a increasingly large set of top line initiatives within traditional businesses that can benefit from basically computing that involves more advanced math than us humans are capable of.
Okay. I would believe that, right? I've seen some stuff that I can't even believe happens, right? Especially from, you were talking about the iterative form. I mean, we use that in marketing with personalized websites. Same type of deal. A human just can't do that.
Right. And then, we go from iterative to highly experimental, which again, I think of as like 100 to 1,000 times, more change within the same time period. And, we just, some of the old stuff, like some of the general concepts, focus on the business problem, still absolutely stays. But because of all that change, there are some other things we need to do. So, anyway, I think there was step number two there, Scott, we might have just missed, was saying that the data scientists are training and preparing and creating these models. And yeah, we have to have a model that performs accurately enough on a historical test. Blind testing a historical data set is kind of step one. And that's, with regard to modeling. That's the point at which we then want to start bringing in the subject matter experts in the business in a more meaningful way to understand the model's strengths and weaknesses in ways that data scientists typically can't from the data alone, that really requires that collaboration between the folks who really understand the patterns in the data that we're able to generalize, and combining that with the subject matter expertise in the business is just essential for taking models that perform accurately on historical data sets and starts to become socialized and develop trust among how that model will perform on future questions, which is really the big concern of the strategic decision makers, right? If I'm going to bring in something new, yeah, it was great in the past, but how is this going to perform on my next decision? And when that next decision has to be right, it can be a more challenging process than, as we discussed a little earlier, the businesses that have the luxury of being able to introduce AI into some some highly valuable business cases that are very fault tolerant, i.e., that you can be wrong a lot and still make a lot of money.
Okay. So I
So
think um, what we're going to talk about and really to summarize, kind of our setup is, maybe the last mile is part of the hardest part, right? It's the highest rate of failure, maybe. And you're going to talk about how, we help companies with their AI projects and kind of the last type of steps, right?
Yeah, exactly, Scott. And it really, it comes back to the data there again. Once we have a model, we trust the model. We've got to be able to interact with it both in a transparent way and then be able to automate it. And by the way, let me just take one more second on this slide. I think AI is one of the most challenging buzzwords certainly in my career because virtually everybody has a different definition of it. This just feels like an appropriate time to share kind of how we think of machine learning and AI. So machine learning are these algorithms that extract generalizable patterns from data using advanced math, and then the computer writes its own program that essentially codes this conditional logic that again is more complex than code that humans can write, and we wind up with a model. A model is anything that takes a set of inputs and returns an output. In this case, machine learning models are models that we create using machine learning. We think of AI as running machine learning autonomously with a closed feedback loop for continuous learning. So if we're interacting with machine learning models and manually, which is the right start for a lot of this, we kind of think of that as machine learning empowered workflows. When we trust the ML enough that we can run it autonomously, and we have the right data infrastructure in place to be able to continuously train and improve those models, that's what we think of as AI.
Perfect, perfect. And I think you're going to talk a little bit maybe how that does run autonomously. So walk us through kind of how Krista works for some of these projects, and then we'll go through our case study.
Sure. So we've been working with financial services firms on both buy side and sell side, especially for private companies, which, kind of unlike big public companies, there's just not nearly as much data readily available to understand, A, the set of companies that are, potential, to potentially acquire or to sell. I guess it would be to acquire. We use a buy side. So we want to just identify, what's the list of companies that I might want to buy, and then from that kind of larger list, which are the ones that I do want to buy, and then from there, it's what's the right price for them, and that's a very fundamental process, but it's highly manual today. There's just teams and teams of MBAs at these private equity firms and investment banks and all kinds of different family offices who are manually parsing through all this data, full time. It's, 14, 16 hours a day, and then maintaining these Excel spreadsheets. And, this works up to a point. There's a relatively low, ceiling on how much data, you can accurately crunch manually, as well as the, total accuracy and efficacy of the information that's available with a manual centric approach to this.
Okay. Yeah, manual. It seems like that would be pretty difficult. I would imagine if you're doing this type of work, the size of the spreadsheets would dwarf anything that I'm used to.
Yeah, Scott, they certainly can. Those spreadsheets can get really big and complex. And quite frankly, sometimes one of the hardest part, the most time-consuming parts is taking those big complex ones and then summarizing them for the executives. And then every time there's new information, something changes. Now there's multiple spreadsheets that have to be maintained and updated, and that's all really done at the expense of pursuing new business.
Yeah, yeah. All right. So we've taken all of our systems on our previous view and we've strung it out into this workflow. What does this mean? So if I have all these different inbound systems and company informations and CRM systems and different cap tables, what is this process?
Sure. So Scott, I think we've got the presentation set up here to kind of break this down one piece at a time. But essentially, what we're looking at here is a three-step process that really generalizes to buying and selling virtually anything. So the first thing is from the set of possibilities, identifying who should I call, what companies might I want to acquire, or what companies even are available to be acquired that meet certain criteria. And then there's kind of two flows on this. One is typical business development, where companies will source, in this case, these middle market focused companies source data from products like Capital IQ or PitchBook, and then they store that data often in a CRM. Deal Cloud is a kind of industry specific one, and then a lot of these firms also use more traditional products like Salesforce and Sugar CRM, and then they'll manually analyze that data, do their queries, build their lists, and help identify, who is the set of companies I want to reach out to learn more. In the banking case, there is also, the companies that have hired an investment bank, and these are just some of the kind of middle market focused investment banks. These banks will prepare a PDF summary of the companies, and then send those to likely buyers. So there's two paths to identify the set of potential companies that are available for sale. And one of the things that we're doing with Krista is automating enrichment of this limited, publicly and subscription-based data. So we're automating searching of the company's websites, scraping the information off of there, and identifying, things like who's the ownership, mutual connections with the management teams, financing history where that's available from sources like Crunchbase, and then also using LinkedIn to mine information about the businesses as well as the employees there, which really facilitates automating the process then of enriching the publicly available data for the purposes of making a more informed decision and enabling more automation, because again, the data that's available in the public domain on these companies, and there's like hundreds of thousands of them, is very limited. So I'd say the structured data in the public domain that's readily available is limited. So doing some of this automated enrichment is a key piece of the strategy to be able to fully automate building these lists of who should I reach out to if I'm interested in acquisitions.
Yeah, much different than a public company, right? Where there's all type of information available.
Right. Annual reports and then all that stuff. That's a mature space, but there are comparatively very few of those large public companies relative to the numbers of small private ones.
All right. So earlier that process, it asked who should I call, and this one it says who do I call back.
Yep.
Is that kind of like the right prospect for me? What does that mean?
Yeah, this is just making a short list. So first step, who should I call? That's who am I reaching out to? What is the set of available possibilities? And then from that, we want to make a short list of the companies that we might reach out to and make an offer. Really do a deep dive on. So there's kind of two. We just want to stack rank these of the set of possibilities. We want to prioritize which are the ones that we would really like to acquire. And in the case of these confidential information memorandums, which are what the investment banks prepare for the potential acquirers of these businesses, it's really just a big PDF presentation that tells all about the business. The strategy, typically they'll include some of the historical financials, information about the ownership and management team, customer synergies, supply chain synergies, things like that, technology highlights. And it's a huge process for humans to manually go through all that content, read it, mine it out into kind of a structured standard form that is a prerequisite, like some kind of scorecard concept for comparing apples to apples as we're stack ranking our possibilities, especially our most attractive possibilities that are coming in both through the diligence that we are doing, traditional business development, as well as these inbound leads that in this example are coming in from the investment banks.
Okay. And so I've got all this enriched data and structured data, and then I've got some reports. And now I'm looking into pricing, right? If I'm trying to buy or sell something, in your example, this is how to sell anything, right?
Right.
So how much is that? Is Krista now helping us figure out maybe profitability, margin, costs, revenue? What part of this business process is Krista doing?
Right. So Scott, I mean, ultimately, whether we're buying something or selling something, one of the most fundamental drivers of what the right price is the impact on future cash flows. So if we're buying a business, what are their future cash flows going to be? If we're thinking about buying something for our business, is how much is this going to enhance our future cash flows? And that's a place where we can augment traditional, again, manual human approaches with some predictive pieces, by making direct connections into the finance systems, the accounting systems, as well as the cap tables and some of the other systems within these businesses. We're able to, and most of our companies, by the way, Scott, because this is something you can't be wrong about. This is not like, recommend ads or recommend movies or recommend, products online. This is a case where these are high consequence, high cost decisions that have to be right. So the way that we operationalize machine learning here is not to just go from like the old approach, shut that off, stop doing it, and start running fully automated AI. It's to introduce the machine learning in a transparent way that shows you the predicted deal quality and deal size kind of in the middle step on the who should we call back, and predicting the deal quality, the deal stage of the future revenue that this company is forecasting, by making connections into their CRM and their accounting systems. But then going one step further, using all of that data to do predictive modeling about their future cash flows, which is initially we recommend is used in a complementary way to the human analyst who is developing, the models that support that due diligence. And when you get two votes in the room and they agree, you have higher confidence than if you're only doing your old manual approach. When they diverge, those are the places where, having the humans really focus on that is going to create the most value. Because something that AI doesn't have, and I believe is the most valuable part, one of the most valuable contributions that humans make, is our judgment. When we don't have data, when we have one sample, all we have is judgment. But even as we start to get more data and are able to develop these models using machine learning techniques, human judgment for the high consequence, high cost, especially initially as we're starting to roll this machine learning in, is absolutely critical. And it's a piece that I think is often missed. So that's this is holistically then how we are approaching augmenting a traditional business development process with NLP, essentially teaching computers how to read, automating a lot of data enrichment around that, structuring data around that, and then using that larger data set in a predictive way to stack rank and prioritize who we call back, as well as to estimate the true value of these businesses.
That would be a good tool if you're making one of those, like you said, high consequence, low data decisions. And not going with your human judgment, your human intuition, because like, hey, maybe I like the owner, maybe he likes golf like I do, or cycling like I do. You could lessen that criteria and use the data to your advantage. That's a pretty cool way to do it.
Yeah, and I think, Scott, that the biggest takeaway for the folks on the webinar is that those can be complementary approaches. Keep doing what you're doing, add the AI and machine learning smarts, and run them together until the traditional way of doing things becomes superfluous, because the AI machine learning is just so accurate, so right, so much of the time, that we can really trust it fully. And by running them in parallel together is the shortest path to get to that fully enabled autonomous AI.
Okay. Yeah, one of our customers says it helps him scale and find the right opportunities, per that process that we outlined. So it's a really interesting study. So I want to get, we got a couple minutes left, and I want to talk about, how really Krista works on all of this process. What is, you talked about intuition and judgment, and earlier you talked about trust with machine learning. What does that all mean, and how does Krista kind of ease into that?
Sure. So data scientists typically think about trusting a model in a statistically centric way. And through experience, I have found that doesn't translate well into business users developing trust in models. Business users really need to use them in a transparent and collaborative way where they can see it side by side. And that's kind of what we call our low confidence mode. So with Krista, we have the ability very deliberately to introduce machine learning side by side in traditional workflows without having to write a single line of code. That concept stays in place even after we start to develop higher confidence in these models and kind of flip the switch and start letting them run autonomously. When we have in autonomous mode, the Krista is architected to only make decisions autonomously when she has high confidence in the model's predictions. And there's kind of the scope of how we do that is beyond this webinar. It would be a great thing to follow up on for anyone who's interested in. But if Krista has low confidence, she asks for human intervention. By default, that's the mode we start in. As the AI matures and the decision makers' trust in the AI improves, we have the option to switch to run autonomously when we have high confidence, which Krista will do, again, unless she finds places where we need the human input. And that's a very different way to adopt AI than most companies are doing, especially in these digitally non-native businesses. So this one has a huge impact on reducing the failure rate for the organizations who can train a useful model. Where organizations are struggling with the technology, we can help with that too. But for the organizations that have useful models that they are failing to make valuable, this operational approach is a game changer, and we're seeing that across our customer base.
Okay, that makes sense. You don't want to jump in with both feet. Maybe put a toe in the water and kind of learn as time goes on, but not a whole lot of time, right? So what does what does Krista do in terms of getting it into production and kind of operationalizing this? We'll just sum it up here. I think this is our last slide.
Yeah. So, Scott, part of our vision is to enable our users to collaborate with humanity's collective artificial intelligence. Some of the machine learning models that support that we provide to our customers. Some of that our customers already have. And then there's just an increasing amount of potentially highly valuable AI and machine learning that's available from all kinds of other vendors, as well as the big cloud providers. So we want to enable our users to incorporate these models into their workflows as quickly as possible, and in a codeless way be able to interact with all the other systems and all the other models that they need to be able to get the inputs to the model that they're introducing. And that low code, or that truly no code experience, that is as easy as text messaging, um, is not in common practice yet. But what we're seeing is with our the customers we've rolled this out to, is that it is enabling them to confidently get to a place where they are running mature machine learning autonomously. And this is a profound thing for a chief data officer. They're doing it with a lot less data than their competitors because of the openness and the collaboration with the machine learning that is running in production.
Interesting. Well, thanks, Luther. If anybody has any questions, you can email Luther at kristasoft.com. He'll be glad to answer a private question. We get more questions offline than we do on the webinar, so completely understandable. And then tons of information on kristasoft.com. Check us out there, and we'll have the archive video and the slides available probably later today or tomorrow. But Luther, any closing thoughts for our audience members today?
Scott, just thank you all for your time. We hope you found this useful, and really look forward to the opportunity to show you what this all looks like behind the scenes. Thanks.
All right. Well, thanks, Luther, and really appreciate everyone's time. And stay safe out there. Bye.